Okay, class, in this lesson, you are going to learn to use both the law of sines and the law of cosines to solve for unknown angles and sides of a triangle. Okay? All right, so let's go ahead and get started with both the laws. Okay? Here, what we're saying in this triangle, if you take a look at this triangle where all the black letters are angles and all of the red letters represent side length of each side of the triangle. And what this is saying is that the ratio of the sine of this angle divided by the side opposite that angle is equal to the sine of this angle divided by the side opposite that angle, which is this, B. And then that is also equal to the sine of this angle, angle C, divided by the side opposite that angle, which is C. Okay, so the law of sine says sine of A divided by A is equal to sine of B divided by B is equal to sine of C divided by C. So all these big letters are angle measures, and then the ones in red are the lengths of the sides of the triangle. Okay, and then the law of cosine, which is a little bit more complicated, but if you focus on just the first one here, okay, right here, this first one here, okay, and if we focus on just these three components here, meaning we're looking at angle A, which is right here, and then the sides that make up that angle, okay, so side C and side B make up angle A. And what the law of cosine is saying is that if you take this side squared and you add this side squared and you subtract 2 times this length B and times the length C and multiply it by the cosine of this angle, then what you will get is this side, which is opposite this angle, squared, okay? And so that's what this law of cosine says. A squared, which is the side opposite of the angle that we are referring to. So if we take this squared, that's going to equal B squared plus C squared, which is this side and this side, which make up this angle, minus 2 times the product of B and C times the cosine of A, and that gives you that equation, okay? Now, these other variations, or these other equations, are just variations of different angle, okay? So if we're looking at this angle and these two sides, then what it's saying is this squared is going to be equal to this squared plus that squared minus 2 times this times cosine of B, okay? And then the last one here is the same thing here, but now we're looking at angle C and these two sides. So basically what it's saying is this side squared is equal to this side squared plus that side squared minus 2 times this times cosine C. Okay, so those are essentially the law of sines and law of cosines. So let's go ahead and apply these to a couple examples. And let's go ahead and go to example 1. Okay, so here we have a triangle, XYZ, and we're given this angle. We're given the length of the side opposite this angle. Okay, that's important. And then we're also given this length, which is the length of XY, and we have to find this angle. Okay, so what this means is we can use the law of sines to solve for this. Okay, well, how do we do that? Well, we're going to say that the law of sine, as you know, is sine of A over the side opposite that angle, then that's equal to sine of B over side B. Okay, now we can convert this to say sine of X over 1,000, because that's the side opposite sine of X, and that's going to equal the sine of Z, which is what we're solving for, right? This is the angle we're solving for, divided by the side opposite that, which is going to be 1,200. Okay. Now, we know what sine of x is. Sine of x, well, x is 32, so we can go ahead and replace that with sine 32 divided by 1,000 is equal to sine of z divided by 1,200. Okay. Now, if we cross multiply, meaning we multiply these together and then these together, we find that 1,000 sine of z is equal to 1,200 sine 32. And then we find that sine of z is equal to 1,200 sine 32 divided by 1,000. Okay, and if we punch those numbers into the calculator, 1,200 times the sine of 32 divided by 1,000 would give us a value of 0.636. Okay, and then if we take the inverse of that, we find that z is equal to 39.5. So angle z is 39.5 degrees. Okay, now here's another example. We want to find the length this time of JL. Okay, the length of JL. Well, we have the angle of 75 and the length opposite that angle, which is 90. And we have this angle, but that's giving us the length opposite of JK, which is not what we want. We want the length of JL. So in order to get the length of JL using the law of sines, we have to know what this angle is. Well, we can easily solve for this angle because we know that the sum of all three angles in any triangle add up to 180. Okay? So what that means is we subtract 180, or subtract 75 and 60 from 180. That means that 180 minus 60 and minus 75 gives us 45 degrees. Okay, so now we know that this angle is 45 degrees. So now we can use the law of sine to solve for side JL. I'm going to say JL is going to be, we'll call this x. Okay, so if we use the law of sines, then what we will get is the sine of 75 over 90 is equal to the sine of 45 over x. Okay, so sine of 75, so the angle divided by the side opposite that angle is equal to the angle 45 over the side opposite that angle, which is x. So then we go ahead and cross multiply. We're going to cross multiply these and cross multiply these. Okay, and so what we get is sine 75 times x is equal to 90 sine 45. So that means x is equal to 90 sine 45 divided by sine of 75. Okay, and we punch that into the calculator. 90 times the sine of 45 divided by the sine of 75 gives us 65.9. Okay, so the length of JL is therefore 65.9. Okay, let's move on to the next example where we're now going to have to use the law of cosines. Okay, so as I said before, we want to focus on the angle and the sides that make up the angle. So these are side TU and side TV. They make up this angle 65, okay? And so we're looking for the length of side T, and so we're going to use this law of cosine to solve for that, okay? And so my a squared here is going to be my T, so then I'm going to rewrite this equation as T squared is equal to 9 squared plus 17 squared, and it doesn't matter which one you assign B or C to. Okay, the important thing is to take these two sides and square them and add them together, and we're going to subtract the product of 2 times 9 times 17 times cosine of 65 degrees. Okay, punch those numbers in, and let's see, 9 squared is 81, plus 17 squared gives us 370. And then the product of 2 times 9 times 17 times cosine of 65 gives us, let's try this again, times 65 cosine is 129.3. Okay, so that means t squared is equal to 240.7, and then we take the square root of both sides and we find that t is equal to 15.5. Okay, so the length of UV, or in this case t, is 15.5. Okay, let's move on to our last example. And here we're going to need to use both the law of cosines and the law of sines to find angle C. Okay, now why is that? Well, we can't use just the law of sines because the law of sines says we have to take the side opposite the angle, okay, divided by this side, which is what we're looking for, but then we don't have any of the other angles to create that ratio. So we have to find one of these angles first, okay? And so to do that, we're going to find the length of this side first, okay? We're going to do that by using the law of cosine. And the reason we're going to find this side first is we have this angle here, right? And these two sides that make up that angle. So we automatically will know this. And if we have this, the length of this side, now we could take this ratio using the sine, law of sine, take the ratio of sine of 68 over this, the length of this side, which we will calculate. And we could set that equal to the sine of C over the side opposite, which is 1.2. Okay, so let's go ahead and find this first. And we're going to call this side x. Okay, we'll call that x. So using the law of cosine, okay, we'll see that x squared is going to equal the sides squared, the sum of the sides squared, okay, minus the product of 2 times 1.2 times 5.3, okay, and we're going to take the cosine of that angle. In this case, it's 68, okay, so then x squared is going to equal, well, 1.2 squared plus 5.3 squared is equal to 29.53. We're going to subtract the product of 2 times 1.2 times 5.3 times 6 cosine of 68, and that gives us 4.76. And adding that together, x squared is going to equal, let's go ahead and punch this in again, minus 4.76 is equal to 24.77. And if we take the square root of both sides, we get 5, okay? Rounds out to 5.0. So the length of x is now 5. So we know this is 5. Now we can use the law of sine to find the angle C, okay? So let's go ahead and set those ratios. We're going to say that sine of 68 over the side opposite it, which is 5, we just figured that out, is going to equal the sine of C over the side opposite that angle, which is 1.2. Now we're going to go ahead and cross multiply those. And when we do, we get 5 sine C is equal to 1.2 times the sine of 68. Okay, sine of C is going to equal 1.2 times the sine of 68 divided by 5. And if we punch that into the calculator, we get sine of c is equal to 0.22. And then to solve for c, we take the inverse sine, and that comes out to 12.9 degrees. Okay, and that is how you solve for angle C in this example. Okay, so hopefully that made sense to you. If any of this was unclear, please go back to the beginning of the recording and listen to it again. Thank you.